Nour, what are you up to?
Oh, hey, Vanessa. Nothing much, just daydreaming about the projectile motion my horse makes over a fence. How about you? What are you up to?
Oh, nothing much. I just got back from my daily displacement ride with my biker gang. Hell's Angles.
Hell's Angles? How lame.
Excuse me? I bet my acceleration on my bike is faster than your acceleration on your stupid horse.
Really? You want to bet?
Yeah, how much?
My whole tuition. Oh, wait. We're both too broke for that. But anyways, my super awesome horse versus your super lame bike.
It's on.
Okay, so basically these are our 5 kinematic equations that we're going to use to help us determine our acceleration. We have 2 unknowns, and we have 3 things that we already predetermined. So our distance, we measured both to be, we set them to be equal, so 50 meters. The time on the horse was 9 seconds, time on the bike was 10, and both of us started with an initial velocity of 0 because we both started from rest. So we have 2 unknowns. We can try to determine one unknown first, which is our final speed, and then it will help us determine acceleration from one of these equations. So I'm going to use this equation, equation 4, to determine the final speed. So my delta x is 50 equals 0, which is my initial speed, plus v final, my unknown, divided by 2 times 9 seconds. I'm going to get a final velocity of 11.11 meters per second. And now that I have a final velocity, I'm going to use equation 3 to help me determine acceleration. So again, we have all of these, we just don't have the acceleration, so now I can solve for acceleration. So I got 11.11 meters per second squared for my final velocity. 0 squared is just going to get canceled out, plus 2 times the acceleration times 50 meters. I get an acceleration of 1.23 meters per second squared, which are the units for acceleration. And obviously, if I were to use any of the other equations to solve for acceleration, I should still get the same value.
So we're going to do the calculation for the bike this time. We're going to use the same equation as Nour used before. So it's going to be delta x equals v initial plus v final over 2 times time. So I'm just going to plug everything in. The only difference is going to be the time is 10 seconds instead of 9. And your final velocity should be 10 meters per second. And from there, you can use any kinematics equation to obtain the acceleration. So instead of using this one that Nour used here, I'm going to use this one over here. It's going to be v final equals v initial plus acceleration times time. Plug everything in and then solve for acceleration. And your acceleration is going to be 1 meter per second squared.
What does that tell you? That my acceleration is greater than yours. Not only do I have a greater acceleration, my horse is better, my ride is better, your biker gang is still lame.
We can redo this. We can measure the angle. We can measure the projectile motion. I'll go up a ramp. We can measure the forces.
Nah, I'll just take the win.